Hello, science lovers, and welcome back to the channel. Today, we're pulling back the curtain of history to reveal a story that was almost lost to time. A story of a brilliant mind, a forgotten discovery, and a woman who saw the world in a way no one else had before. We often associate the discovery of the greenhouse effect with names like John Tyndall or Svante Arrhenius. But what if I told you that the very first person to identify the mechanism that warms our planet was an American woman, an amateur scientist, an inventor, and a passionate advocate for women's rights? Her name was Eunice Foote, and her story is one of sheer genius that deserves to be shouted from the rooftops. To truly appreciate the magnitude of Eunice Foote's achievements, we first need to step back into her world. Born in 1819 in Goshen, Connecticut, Eunice Newton Foote grew up in an era where the roles of men and women were rigidly defined. The 19th century was governed by the ideology of separate spheres. The public sphere of work, politics, and science belonged to men, while the private sphere of the home and family was the domain of women. For a woman to pursue a formal education in science, let alone a career, was almost unthinkable. Universities like Harvard and Yale were closed to them. Scientific societies were exclusive boys' clubs. The prevailing view, steeped in patriarchal tradition, was that women lacked the intellectual capacity and the physical fortitude for rigorous scientific inquiry. Their minds were considered too delicate, too emotional for the cold, hard logic of science. But Eunice Foote was not one to be constrained by convention. She was fortunate to attend the Troy Female Seminary, one of the first institutions in the United States to offer young women a science-focused education comparable to that available to men. There, under the influence of educators like Amos Eaton, a co-founder of the Rensselaer School, now Rensselaer Polytechnic Institute, her natural curiosity was nurtured. She learned chemistry, biology, and geology, developing a solid foundation in the scientific method. This was not just a finishing school. It was a crucible for a new generation of educated women who would go on to challenge the status quo. After her education, she married Elisha Foote, a judge, patent lawyer, and inventor himself. Their partnership was one of intellectual equals, a rarity for the time. Their home in Seneca Falls, New York, became a hub of intellectual and progressive activity. Foote's passion for justice and equality wasn't limited to the laboratory. She was a core part of one of the most important social movements in American history. In 1848, she and her husband Elisha attended the historic Seneca Falls Convention, the first ever women's rights convention. This wasn't a casual attendance. Eunice was deeply involved. She was a member of the editorial committee and, most notably, was the fifth person to sign her name to the Declaration of Sentiments, the convention's foundational document that boldly demanded equal rights for women, including the right to vote. Her signature appears just below that of the legendary Elizabeth Cady Stanton. This act alone tells us everything we need to know about Eunice Foote's character. She was fearless, principled, and believed fervently that a woman's voice and intellect were equal to any man's. Her fight for social and political recognition was intrinsically linked to her pursuit of scientific knowledge. For her, the freedom to vote and the freedom to experiment were two sides of the same coin, the fundamental right to participate fully in the world. This context is crucial because it shows that her scientific work didn't happen in a vacuum. It was an extension of her rebellious, forward-thinking spirit, a direct challenge to a world that sought to limit her potential. She wasn't just a scientist, she was a revolutionary. And it was this revolutionary spirit that would lead her to a discovery that would, over a century later, become one of the most critical scientific concepts of our time. So, how did this activist and inventor, working from her home laboratory in the mid-19th century, make a discovery that would elude the world's leading male scientists for years to come? The answer lies in the elegant simplicity and profound insight of her experiment. The year is 1856. While the scientific community is focused on grand theories and complex apparatuses, Eunice Foote is using materials you could find in any well-stocked study. Her setup was ingenious. She took two identical glass cylinders, placed a sensitive thermometer inside each one, and sealed them tightly. She then used an air pump to remove the air from one cylinder and fill it with a specific gas she wanted to test. Her first key experiment involved filling one cylinder with normal moist air and another with very dry air. She placed both cylinders side by side in the bright sunlight and watched. She observed that the cylinder with the moist air, containing water vapor, became significantly hotter than the one with dry air. That was her first clue. But then came the masterstroke. She decided to test what was then called carbonic acid gas, what we know today as carbon dioxide, or CO2. She filled a cylinder with this gas and placed it next to a control cylinder filled with common air. The results were dramatic and unequivocal. The thermometer in the carbon dioxide cylinder soared to a temperature of about 125 degrees Fahrenheit, around 52 degrees Celsius, far hotter than the cylinder with regular air, which only reached about 90 degrees Fahrenheit. But her observation didn't stop there. She noted something else, something just as crucial. When she moved the cylinders into the shade, the cylinder containing carbon dioxide took many times as long to cool down as the one with normal air. She had not only discovered that carbon dioxide gets hotter in the sun, but that it also traps that heat, retaining it for much longer. This is where Eunice Foote transcends from a mere experimenter to a true scientific visionary. She didn't just record her data, she made an enormous intellectual leap and connected her small-scale tabletop experiment to the entire planet. In her paper, titled Circumstances Affecting the Heat of the Sun's Rays, she wrote the words that should have cemented her place in history. An atmosphere of that gas would give to our Earth a high temperature, and if, as some suppose, at one period of its history, the air had mixed with it a larger proportion than at present, an increased temperature from its own action, as well as from increased weight, must have necessarily resulted. Let that sink in. In 1856, Eunice Foote explicitly hypothesized that a higher concentration of carbon dioxide in the atmosphere would lead to a warmer planet. She had, in essence, discovered the scientific basis of the greenhouse effect. Her paper was accepted for presentation at the 8th annual meeting of the prestigious American Association for the Advancement of Science in August 1856. But as a woman, she was not permitted to present her own findings. Instead, a respected male colleague, Professor Joseph Henry of the Smithsonian Institution, read it on her behalf. While he praised her work, his introduction was tinged with the condescension of the era, stating, "Science was of no country and of no sex. The sphere of woman embraces not only the beautiful and the useful, but the true." The very act of him reading her work for her underscored the exact barrier she faced. Her paper was later published, but it was largely ignored, overshadowed, and ultimately forgotten. 3 years later, in 1859, the Irish physicist John Tyndall, using more sophisticated equipment, published his own, more detailed research showing the heat-trapping properties of various gases, including carbon dioxide. Tyndall had the backing of the British scientific establishment, published in more prominent journals, and as a man, his work was taken seriously. For over 150 years, he was credited as the father of climate science, while Eunice Foote's name faded into complete obscurity. It wasn't until 2011 that a retired geologist, Raymond Sorensen, stumbled upon her paper and realized its monumental significance, finally beginning the process of restoring her rightful place in history. So next time you hear a discussion about climate change or the greenhouse effect, remember the name Eunice Foote. Remember the woman who, with just a couple of glass cylinders, a few thermometers, and a brilliantly inquisitive mind, was the very first person to grasp the fundamental relationship between carbon dioxide and our planet's temperature. She was a visionary, a pioneer, and a testament to the power of a curious mind to see what others can't, even when the world is trying to keep its eyes shut. Thank you so much for joining us on this journey to uncover a hidden piece of science history. If you found this story as inspiring as we did, please give this video a thumbs up, subscribe for more stories of forgotten science, and make sure to hit that notification bell so you never miss our next deep dive. We'd love to hear your thoughts in the comments below. Who is another forgotten scientist whose story we should tell? Until next time, stay curious.